In this video, we will explain the second type of potential energy, the elastic potential energy. Elastic potential energy is potential energy stored as a result of deformation of an elastic object, such as the stretching of a spring. And elastic objects are known as the objects that are able to return to their original shape after being stretched or pulled. And examples on the elastic objects are the rubber bands, rubber balls, or as we said, a spring. So, by taking an example of a spring that is fixed from one side and left without being touched, there will be no forces acting on it. But after stretching the spring and we pull it to the right, and as we know, for every action there will be a reaction. So this pull force that we made on the spring will be equal and opposite in direction with the force made by the spring as a reaction. So if we name this point 0, the origin of the natural state of the spring, and we measure this length notated by x, we can find the elongation that we made turning the spring from its natural state to its elongated state. Therefore, the elastic potential energy will be equal to half kx squared, where x is the displacement or elongation of the spring, as we said, and k is the spring constant, or also can be called the stiffness of the spring. The elastic potential energy will be equal to 0 when the spring is in its natural state, because there was no elongation x. As you can see, x was equal to 0. While the elastic potential energy will be equal to its maximum when the spring is stretched to its maximum point. And at last, when the spring is released, the elastic potential energy will be converted to kinetic energy and will be also transformed into other types of energy, such as sound energy and heat energy. And for sure, in this case, the energy will be conserved, as we learned in previous tutorials. Therefore, the potential energy plus the kinetic energy will be equal to the mechanical energy.